I think we're going to get started so that we make the most out of time, and people will filter in as they finish lunch. But thank you all for being here. For a topic that I feel very passionately about, I'm very really grateful that SANBio invited me to come and speak about this topic and invited all of us here on the panel to be part of this, and I'm glad you are all here. We've spent many hours over the last 2 days talking about how you commercialize the results of research. But it's been touched on by a number of the speakers, the problems inherent in doing that research at all. And you know, when I think about it, basic research itself really, right, it is the spark for all innovation. You cannot have a product if you did not have a lab. You don't have the resources to do basic research. And you certainly can't train future innovators if you don't have the facilities to do that. So when I think about what are the ingredients that are required for a productive, cutting-edge research ecosystem, and there are many. These are the ones that stuck out to me the most, but I'm sure it's not an exhaustive list. Right, and there are each and every one of these issues is complex in and of itself to solve. Right, this is not a trivial problem to create a thriving research sector, but one of these components, one of these ingredients has always stuck out to me as being the most overlooked, and that's around infrastructure, particularly scientific instrumentation. Infrastructure is never glamorous. It's never the sexiest thing you can talk about, right? And this is true across anything: roads, bridges, dams, power plants, railways. Infrastructure is often neglected. It's often a source of underinvestment because it's the least glamorous. You can't put your name on a road or a bridge. You can't, if you're in government, it's built long after your term. And so there are lots of reasons why infrastructure is often pushed to the background. But we recognize to some extent that infrastructure is a critical component of economic advancement, right? And that's why we continue, when we do, to invest in roads and bridges and dams and power plants. And I would argue that in this century, scientific infrastructure is equally critical as an ingredient for economic development. And so we have to invest in it commensurately. We have to start to think about it as just as important, on par with having power generation or highways to drive on. And so I'm thrilled that we have an ability to have this topic today at hand to talk about some of the problems inherent in scientific infrastructure. And there's a number of speakers here. I'm going to try to limit the formal introductions, not to diminish their importance as speakers, but so that we can maximize the most of their time in hearing their actual thoughts and information. So the first person that I would like to introduce is Professor Kenneth Matengu, who is the Pro-Vice Chancellor for Research and Innovation at the University of Namibia.
Thank you very much, Nina. Good afternoon, colleagues. I will be very brief. I'll try and give a perspective from my university administration in terms of what is the importance of research infrastructure and why we have the limitations that we tend to see. And then I will be concluding in sort of saying or highlighting the expectations that society or governments have on research institutions. Am I clear enough, or should I speak more louder? I'm clear, okay. Good, thank you. So I think the first question we need to be asking, when we say we need research infrastructure for the future, it's for what? This infrastructure is to serve what purposes? And for whom? Or one can even say, you have this infrastructure, so what? Is it to develop science for its own sake? Which is also important, but also science for certain purposes. Some of the purposes may be political, it may be economic, or it may be social. But it has to be defined ahead of time so that when you are procuring or you have this infrastructure, it is enabling and speaking to national policies and development and global agendas. And of course, this infrastructure may be for teaching. As Nina highlighted, we need to have basic sciences and basic infrastructure to be able to ensure that we have the foundation for which innovation can thrive. But there has been criticism, if you read in the literature, that the higher education sometimes tends to be more academically, focused more on academic training, academic education, rather than skills education. And so the component of training there is very important, so that we don't only produce people who have knowledge, but who have the skills to be able to take the knowledge that they gain out of universities into products. And of course, it could be for business, but more importantly, also for social equity. Because if we are not careful, we may have certain infrastructures, and the knowledge that comes out of that may advance inequities. Because knowledge and research outcomes are consumed, but they are not consumed by everybody. There are those who may be capable of absorbing and consuming that. There are others who may not be very capable of doing so. And it has implications. As some of you know, the whole debate around this in terms of the whole idea of education and capitalism. So we have got to be very careful. I think I have addressed the question about who has access to this information, and are we ready? And in this case, looking at Africa and Southern Africa in particular, we may invest very heavily in infrastructure and innovation, but do we have the industry that is able to consume that? Or will we be just producing this knowledge and these products and passing on to major international companies that have the capability to take advantage of these? And if we are not, we may find ourselves that we are simply just advancing industrialization and forgetting rural areas. And whereas that is where the major population is. So in terms of, as higher education institutions, as research institutions, as governments, as nations, are we ready for the future of innovation in terms of big data and other things? Now, scientific infrastructure or lack of it is limiting research questions in many universities, including in my own. And part of the reason is because we have human resources that are trained elsewhere, who have been using certain infrastructure. When they come, they find very rudimentary facility that they are not able to use. Or the kind of training they get is heavily theoretical. And the laboratories are not to the state where we need them to be. And of course, many institutions are not deliberately defining the agenda for the creation of centers of excellence for which investments must be targeted. And if they are not defined ahead of time, you would have difficulties in motivating to government of what those are. Because the question then is, of course, you want to have this kind of investments, but if I compare it to building roads or building hospitals or clinics or schools, there's some challenge in that regard. Access to infrastructure is important. We must be talking here about effective coverage. In my view, an infrastructure is accessible only if it is not only available, but it is affordable and acceptable to the community in which you are producing that knowledge. And in many instances, you would find that infrastructure is there, but it is not affordable, even in terms of maintenance. And so it is also important that we look into these issues. Then there's the issue of standards and credibility of what comes out of those labs. I have been in many African countries, and I won't name the university, but I have seen in some universities very good infrastructure, but these infrastructure have been received perhaps through donation or even sometimes bought, but they are covered for 4 or 5 years. Nobody's using them. And there are no standards and protocols of which these must be utilized, and the skilled workforce that is able to do this. So I think the processes of certification and accreditation is very, very critical, especially if the industry will have to have trust in what we do. If it's not there, then we may have certain challenges. I know that there are some of us who think that certification and accreditation is not a requirement for us to do scientific work, but I think it is important that we take into account the needs of the industry. Again, I believe that innovation would thrive very much if we have high-level postgraduate and postdoctoral schemes that are linked to industry and public service needs. If they are just science for its own sake, then we will have some problems. We can be doing, we can have people who may be doing research on sexual behavior of desert dung beetles. But the question would be, what benefit does that bring to development? I do know, though, that in terms of basic science, this is important. As some of you know, that researchers in Japan and I believe in India have worked on the anatomy of the cockroach, which has the heart of the cockroach has 13 heart chambers. So understanding that is important because then you can apply it in terms of the artificial heart that you may make for people. So basic science is important, but it must be linking to the industrial needs that society needs. Then there is an issue, I don't know whether it is an issue of colonialism or so, but there is a lot of mistrust between the industry and public sector, and between higher education and the industry, and within society itself. And I think this issue, we need to really look at it, even in terms of investing in infrastructure, it's a question of trust or mistrust. So what could we do? In my view, higher education institutions or research institutions by themselves are not able to build and procure infrastructure that is needed on their own. Obviously, because of the burden on financial resources coming out from the state. So we have to be thinking of how could we possibly ensure that we have the right kind of infrastructure for the right purposes. And some of the options that could be looked into is leasing, working in partnership with the industry to lease equipment rather than procure or buy them. That way you are able to avoid maintenance costs and replacement, which when it's leased, it would be automatically done. But in my view, these kind of arrangements must not be too much motivated by profits. It should be anchored on the national priorities and development agenda. Obviously, this means that we have to partner more with the industry, with the public service and higher education institutions to be able to make this possible. And those partnerships should be, in my view, defined in terms of who benefits, who is affected, and who is to receive whatever comes out of the innovation and the engagement. I have highlighted already the question of postgraduate. I just want to emphasize that I think if we look at the endowments that comes out of indigenous knowledge, we really need to invest more heavily and strengthen science, separation science facilities in terms of characterization, detection, and separation science facilities. These would be the basics for which we can really take advantage of outcomes of research. And I think that there is really potential in indigenous knowledge if we invest in this. Basic science, as I said, is essential, but it is also, it cannot be for its own sake. The relevance of what we do and how we are seen by society is of priority. And we need to make sure that what we do speaks to how society sees us. And the question of transparency here and accountability is very, very important. As a university, we cannot just hide behind autonomy. We need to be very transparent in our finances, in how we conduct our business, and so on. That way, I think the industry will also have trust. I thank you very much.
Thank you. All right. Thank you so much. I will queue up the next presentation to get us into a little bit more of the detail behind some of the need for infrastructure. Dr. Louise Ziedenhut, yes?
Very good.
Yes.
Hi, everyone. It's a real pleasure to be on this panel because I think it's great to actually find a group of people who are really passionate about infrastructure and about laboratory equipment, which, as Nina has said, is not always the most sexy of topics. So I'm a sociologist of science, actually. And a lot of my work involves talking to scientists in low and middle income countries about the challenges they find in their daily research experiences. So I spend a lot of time in African labs working alongside scientists and chatting to them about what they have problems with on a day-to-day basis. And in that way, I think I kind of come at the same problems, but from the opposite end to our previous speaker. So I hope it'll be interesting. So this quote is actually from a survey that I did with SANBio 2 years ago, where we were asking scientists to detail issues that they had in their day-to-day working environments that stopped them or slowed them down or challenged their daily research experiences. And I like this quote because what this quote is really highlighting is a problem that is not going to be surprising to any of you, that equipping labs is really challenging in low and middle income countries, and particularly for early career researchers who are starting out. There's often not lab spaces that are equipped with equipment that they can just walk into and start their research, and that it takes a lot of time and effort and creativity to be able to source the resources necessary to start a research program and start getting grad students producing data. And what this quote highlights, and what I'm going to be talking about for the rest of the talk, is how these research infrastructures and equipping a lab is not necessarily just the high-level pieces of equipment that a lot of people are talking about, but everything from the glassware you have to the reagents to the very small pieces of lab equipment like water baths or PCR machines or centrifuges, and all of those together combined to create either a flourishing or a non-flourishing research environment. So, as I said before, when I go into these labs, there are a lot of things that people say are challenging them. And what really comes out from all my discussions with scientists is the fact that it's very difficult, if not impossible, to start talking about items of equipment in isolation. And what we actually need to start doing is talking about technological infrastructures within laboratories. So networks of equipment and how they interlink with each other, rather than just thinking about a single piece of equipment. So thus, a PCR machine is only really useful if you take it into a lab, if it's embedded within a network of centrifuges, of reagents, of water baths, and also of the extra laboratory structures such as power and so forth. And it's only if you have this network as flourishing and integrated that you can actually get successful research. So if you start thinking about networks of equipment rather than individual pieces of equipment, it becomes very evident that these networks of equipment are very fragile, and they can be easily disrupted. And this is not necessarily just in the case of a piece of equipment breaking down, but it also could be in a case of adding a piece of equipment that diverts resources or diverts other items in the network towards it instead of towards something else. And therefore, we need to think about how to maintain stable and flourishing infrastructures in these low-resourced environments. So I think a lot of the thinking around, well, the discussions around single items of equipment have its heritage in the way we fund scientific research. And most of the funding that comes into African laboratories is project-specific funding. And project-specific funding is very unusual in the fact that it doesn't necessarily fund all items of equipment. It will fund extraordinary items of equipment, but it doesn't fund the basic laboratory equipment and the other aspects of the technological networks. And thus, the scientists are often in a bind in the fact that they can buy certain items of equipment, but they can't buy the equipment they need for the day-to-day running of the lab. And this is further compounded by the fact that a lot of African institutions do not have the finances available to give the kind of core funding necessary to start equipping these research spaces. So thus, the scientists are faced with problems such as the absence of core funding, so they can't purchase basic laboratory equipment. They're sucked into maintenance contracts that they don't necessarily have the funds to be able to honor. The lack of core funding causes repair problems where they can't hire technicians to repair the pieces of equipment, and they often struggle buying common reagents that are particularly necessary for student projects and so forth. And this is also further compounded by the fact that the absence of core funding also causes an absence in upgrading and maintaining physical laboratory spaces. And therefore, while they may have project funding to do certain types of research, they don't have money to equip their laboratories with benches, with getting an electrician to wire it properly, and so forth. And this creates really challenging environments that can unnecessarily derail really good research programs. So the key problems I've encountered through all my research in laboratories are the fact that these disrupted technological networks slow down research very, very severely. And scientists try to find creative ways, but often are really struggling with the ideas like not having basic equipment available in grant applications, the fact that they're locked into costly and commercial maintenance plans with equipment that comes from commercial providers in high-income countries, the fact that they struggle with repair, they don't have money to be able to hire technicians, but also the fact that the basic laboratory equipment is in very high service regular use. And there are often not repair services in situ, and they'd have to import repair services in. And the fact that they really struggle to source the parts necessary to repair equipment. And then, as I mentioned, also common reagents are really difficult for them to purchase. They're often proprietary, they're imported, and therefore they'd be paying a lot more money for something that could necessarily be sourced in situ, and they need to cost it into grants, which is something that some funders are less keen on than others. So, as I mentioned, we did a survey amongst the SANBio community to look at these issues and how they were experienced by scientists. And there was an open question at the end of the survey asking the scientists to detail what they'd use $5,000 for. It was a very arbitrary sum, but we were really interested in whether small pots of money could actually affect change in the same way large pots of money could. And what we saw was really striking, that there was an overwhelming statement that this small pot of money would be extremely useful by being able to purchase small pieces of equipment, by being able to repair or maintain the equipment, and so forth. So these are the type of things. So what the SANBio survey, I think, really points to, and I'd be interested to have more discussion, is whether we need to start freeing up some funds, small pots of funds, to be able to equip laboratories with basic equipment, and then whether we need to start taking the idea of stable and flourishing equipment networks more seriously in our discussions. And that was me. Yeah.
Thank you.
Thanks.
That is an excellent question, I think, to hold on to for all of us, because I hope that actually we can have a lot of time for discussion and really come away with actionable type solutions, or at least things we might be able to experiment with. I wanted to follow Louise just very quickly, because the problem that we've been addressing for the last 10 years at Seeding Labs is exactly drawn from the same set of observations and data that I think Louise just alluded to. So I'm the founder and CEO of a social enterprise. It's based in the United States, in Boston, called Seeding Labs. The mission is, broadly speaking, to ensure that everyone, everywhere across the world, gets to be full and active participants in driving scientific research and innovation. What I had seen from personal observation and experience is what a lot of you, I'm sure, have seen as well. I also worked in a lab in Africa where we reused pipette tips and Eppendorf tubes and held on to latex gloves for far longer than their actual useful life. And going back to the United States from that experience was incredibly jarring. And that's roughly when I got the idea for Seeding Labs. And the core project that underlies our work is called Instrumental Access, and it's about affordability of laboratory equipment. And one of the things, I'm going to skip some of this, over the last 10 years, we've been collecting data from scientists, not just in Africa, but around the world, around their instrumentation needs. This is just a snapshot of some of what people have reported to us. I know it's very hard to read, but what you can see is anything, as the graph goes out to that direction, these are the highest needed equipment. These are the most requested, greatest needs. And with the four most outlying bubbles there are pipetters, microscopes, balances, and centrifuges. Right, so to follow on what Louise said, yes, absolutely on this graph are FTIRs and GCs and mass specs, but the basic workday workhorse equipment is also one of the greatest needs that people face around the world. And perhaps as a counterpoint to this idea of smaller funds, I guess I would push back a little bit. Pipetter, microscope, balance, centrifuge. These are small, basic examples of each one of those, and if you add up that budget, that's around $5,000. That same amount of money posed in Louise's hypothetical question. And so how do you build massive scale infrastructure with that kind of budget? Project-based funding is almost impossible to do that. We have to do something else. And that's why we created instrumental access, was to think about a way to build critical mass of infrastructure for equipment quickly and affordably. We do this by working with a partnership network. We've built a coalition of, now it's over 147 partners. We're very excited, as of last night, some of you might have seen, SANBio is to be joining in a formal partnership with SANBio. We work across the spectrum of public and private. And in particular, we work very closely with device manufacturers and R&D users in the United States to take advantage of a market inefficiency there in lab equipment, which generates a massive surplus of equipment, both new and used. And so we've built a system to leverage that surplus equipment to transfer that affordably to scientists around the world. We run a massive open call for proposals every year. We're very rigorous in that call for proposals because we know that there are a number of criteria for what needs to be in place at an institution for this equipment to be able to be taken up, installed, calibrated, used, maintained, et cetera. But we've distributed equipment. It would have cost over $20 million new to scientists now in 30 countries as of last week, and it's still counting. And most importantly, what we've seen coming out of these labs is that having equipment unlocks a lot of things, right? Hands-on training for undergraduates. Approximately, we estimated just the 12 institutions reporting last year. So institutions that had had equipment between 1 and 2 years only. And we're already using it to train 9,000 students a year in over 150 courses. It had been used to complete 66 PhDs, theses, and 37 master's theses, projects by students and faculty alike across an incredible range of important topics in medicine, in agriculture, in energy, environmental sciences, and most critically, I think, had been used towards building the sustainability of these institutions. So over almost $1.5 million of new funding secured by researchers using this equipment within 2 years. I think that's really important. And you know, this is absolutely, there are a number of issues inherent in the use and productive and sustainable use of this equipment. But what we wanted to prove was that we could develop a creative model outside of the norms of the regular purchasing system that could meet this need for massive capacity quickly. And now it's my pleasure to introduce two of the folks who've been part of this program who can talk more specifically about their specific cases of what equipment and instrumentation and infrastructure writ large have been able to unlock at their respective institutions. And so the first person I'd like to introduce is Professor Enoch Jonathan from Chinhoyi University of Technology in Zimbabwe.
Yes, good afternoon, folks. Yes, I'm from Chinhoyi University of Technology, and yes, we benefited from Seeding Labs instrument program. Actually, the background is having been trained most of the time in Europe and Asia. There was no problem accessing these toys in the labs. But the day I decided to come back home, that was a beautiful shocker, where I was appointed the founding dean of a School of Natural Sciences and Mathematics, no lab, no infrastructure. How we are dealing with issue of equipment back home, I think there are two, what I would term are force factors. Previously, I think this has been the challenge with us academics. We went through the publish or perish mentality, and now we are at the patent or perish mentality. We are being forced actually into that. And starting from yesterday, I think we are now into the entrepreneurize or perish. mentality. Now, depending on where you are, these three mentalities now are forcing us either to be a player as a knowledge creator, or knowledge integrator, or knowledge leverager. From our country, Zim, we got a new political dispensation, and the executive president summoned academics, and his message was simple. A university is going to make its community prosperous. So that has changed our viewpoint in terms of even looking for instruments. How is it done that? We are out now looking for two types of instrumentation. The first one is the workhorse, which Nina has spoken about. This is an instrument which you use on a daily basis. The other one is the racehorse equipment, which will ideally pole position us, right, as far as entrepreneurizing knowledge is concerned. This comes in costly, but we have found some creative ways of loosening people's purses. How have we done that? We have now sought to be conversant with national policy documents. I think yesterday there was a question someone asked to say, you talk of strategic areas. What are these? How many of us have read the SDGs 2063, the African Union targets, no poverty, no hunger, and all that? These are the documents which our governments hold in their hands when they say we want to deal with malaria. So what we are now doing is all our research programs must deliver on those promises that's addressing tangible issues in the community. When we received the instruments from Seeding Labs, we sat down as a team. There was a push by the country to restock the national head, and we sat down and say, where are we going to fit with this, the national program on national head? I've got a team of physicists, biologists, chemists, and mathematicians. And after struggling for almost 2 months, we came up and say, hey, why not go into ISTRA's heat detection, right? So there we are now. We are fitting into a national program to restock the national head, which is CACO, by providing technologies for ISTRA's detection, which will actually sponsor artificial intelligence, and not artificial insemination, sorry, I'm also a computer scientist. Artificial insemination, right? At the end of the day, this will pole position the country for more economic benefits coming through. So we have changed our mindset to say we are not going to be an ivory tower. Most universities are like a silo, right? But we are now forced to reach out to politicians, talk the language of politicians in courts, in the sense that now we deliver a real science to the community. For example, when we got this equipment, the ministry was forthcoming with close to 300,000 overnight, US dollars, on the back of this equipment. Now our ISTRAS detection technology has gone in for final patenting. We went through provisional. We are now on final patenting. And our university now has been made the national center for Keku breeding program, because we seem to be now delivering in the community. So on the back of that, there is need for us to yes, it's okay, we can moan about money for equipment, but the prime question is equipment to do what? If this equipment is part of an innovation infrastructure, which will determine the capacity of a country to innovate, fair and fine. But if this is just equipment so that we can say 20 journal publications, I think we will continue having a problem. So there is need for a business case in all our bid for instrumentation. Thank you.
Fantastic. Where are you, Governor? Tavi. And last, but certainly not least, Professor Tavi Govender from UKZN.
Okay. Good afternoon, everyone. I'm now going to show you the light of what an African can do when they do have access to the state-of-the-art equipment. I've studied extensively in the US, Sweden, Japan, and France. And from my studies abroad, I've realized that Africans are not restricted by their generation of ideas. They are not restricted by their imagination of the scientific question they want to ask, but they are mainly restricted by the infrastructure. But I'm now going to show you what you can achieve when you have access to such infrastructure. So these are the laboratory facilities that I have built over the last 10 years and that I run. As you can see, we are extensively equipped, and we are most probably the most advanced drug discovery unit on the continent. This is my team. Again, lots of academics think that they can achieve such facilities, run such facilities without a proper team. So this is my team. Professor Kruger was my PhD supervisor. Dr. Maguire was also my PhD supervisor. Dr. Bejnath was my PhD student, who's now a pharmacologist. Per Arvidsson is my mentor, and he's head of drug discovery research at Karolinska Institute in Stockholm, and he was my postdoctoral supervisor. Bare was my postdoc who became an academic, and Professor Naika was my PhD student who now runs my synthesis part of the lab. So let's show you what an African can do. The big problem. Across the world recently, if you read the medical brief or any medical journals, the biggest problem across the world right now are superbugs. So we lose 700,000 people per year to these superbugs, and it's expected to reach 10 million per year by the year 2050. And this is a realistic number. Obama, just before he left his office, he dedicated something like $2 billion just to target this one strain of bacteria. What happened to the money after Trump came in, I have no idea. But even in UK, they are offering billions in order to target this bacteria. And the major problem with the bacteria are the ones that express this metallo-beta-lactamases. To give you an idea, 60 to 70% of all antibacterials given or prescribed are beta-lactams. As soon as the bacteria become resistant to beta-lactams, you can now imagine that we have a huge burden on our hands, and this is what has happened. And the problematic mutation that we are looking at is the metallo-beta-lactamase producing strains, because at the moment, there is nothing in the pipeline, no on the market, no promise to target these strains. So in our lab, we came up with using chelators in order to target this. But the problem with these simple chelators, you cannot patent protect them, number one. Secondly, we've already determined that they have very rapid renal clearance. And then we've also seen that they don't really give you enough accumulation in the bacterial site in order to cure. So we came up with this elaborate synthesis in order to make molecules which are able to overcome these barriers. So the chemistry looks a little bit daunting and scary, and up till now, it is the same for me when I look at this. But how did we achieve this synthesis? How did we come up with this? First of all, these are pictures of my actual synthesis laboratory. And as you can see, it's very colorful, the way I like it. And you can see that it's very well equipped, okay? Also, with basic equipment is one level. You need the advanced equipment. And in this case, I have I'm showing you here an LCMS system. But this is a much simpler LCMS system, which costs maybe $1.5 to $2 million. But then when you want to start doing the higher end, you need the higher, bigger instruments, which this instrument is my little baby. I bought it 10 years ago. I paid $7 million for this then. Since then, we have a lot more of these instruments in the lab, and that's why we're able to do this type of research. So what is the promise, and what have we achieved as Africans with equipment? What we have achieved is new compounds. We have 30 analogs for which target this strain of bacteria for which no one in the world has an answer for, and it's coming from Africa. Then these are just some results that we have with regards to the promise of it. We've completed all preclinical evaluations within our lab. So we've synthesized the compound and finished all preclinical evaluations, including the patent filing. And here we also have just some data to show you, if any of you understand the pharmacology of it, that this is really exceptional results. And I'd like to thank you.
Fantastic. Thank you, everyone. And I'm thrilled we seem to have actually some great time left for actually discussing. The mandate, the marching orders given to me today by SANBio was actionable solutions. So I'm sure that in the next 12 to 15 minutes, we can solve all of the world's problems. But at the very least, hopefully, we can actually come out with some great ideas. I know that this is a topic that cuts very emotionally close to home for lots of people. And I know that probably many of you have personal stories to share on this topic. I do hope that if you have specific questions that can lead us towards a discussion of actual things we might be able to do together in our respective roles as administrators, as researchers, as funders, as policymakers, et cetera, then I would invite anybody to, if you have a question, please press the green button on your microphones in front of you. And do we have any questions from the audience? Yes.
No, can you hear me?
Yes.
Right. My name is Damare Naika. My question is for Louise. You did a survey on R&D labs and the lack of infrastructure there. Have you looked at private labs in the SADC region and on the continent where the barrier to accreditation is due to a lack of infrastructure and competencies to ensure that products are tested according to international standards, and it actually is leading to a barrier to international trade? Have you looked at that, or are you considering looking at that?
Thanks for that. It's a really interesting question. So before I started work with SANBio, I actually worked with the South African Academy of Science, and we were trying to set up a database of all research laboratories, be they commercial, diagnostic, or academic in South Africa. And what we found was that it's quite difficult to track down all the commercial labs who are doing R&D type of activities. They're not necessarily visible online, or you have to go through quite a lot of contacts to be able to find out what they're doing. So yes, I think it's very interesting. It's something I'm very interested in pursuing further, and I don't have any answers at the moment. We've just started trying to track down who's doing what in the SADC region, well, in South Africa, but we'd be really interested to expand to the SADC region.
So if I could just add there, I come from a facility where we tested all perishable products for export from South Africa, and we are now engaged with the Regional Lab Association, where they are looking at providing training on calibrations on ISO 17025 and other standards that labs, government laboratories in the region need in order for them to be accredited so that they can start testing their products for export, for example, or for their own local markets. Because we used to test products from Zimbabwe for export to the UK because they didn't have the necessary accreditations, and I think there's still a gap there. But it would be good if we could have a survey of the region and the status of those private and government laboratories.
I totally agree, and I think maybe that should be an action point to try and scope out the industry sector and see if there is a way to get more communication between the two, and to actually contact people like the NRF and ASF who hold the databases of the commercial sector to be able to start engaging them in conversation. It's an excellent point.
Fantastic. Questions? Yes, in the back.
Thank you. Junior Mtangwa from Zimbabwe. There is the issue of donations that come into play in various forms, like in public laboratories, especially medical, where you have either, sometimes you get these huge donations of very big machines that are really take a lot of space, and they are closed systems such that you only use reagents that are from the same company. So maybe it would be an idea to find out, like as a follow-up to what she has just said, to find out what's going on, because I think earlier on there was an issue of space, laboratory space infrastructure, where you're going to put the equipment. Suppose you manage to get the seeding lab to give you some pieces of equipment, but you find that the whole place is cluttered with these machines that come in form of donations. And also the issue of if anybody has to give a donation, to give it as an open system whereby it's versatile, it's flexible, it can be used for various work. Then the other thing is just a follow-up on the network and perhaps sharing resources. You find that technology changes so fast, and within the region, I think it's a desire. I hope I'm speaking for other people in my like me, where we are saying we need to also move with technology. It's nice to get these basic pieces of equipment, but you find that if you are going to do a PCR using a method that we have to, which is very laborious, it takes 2 to 3 days, because we are preparing the reagents, we are doing this, we are doing that, we are optimizing this and that. And then there's equipment that you can actually also, instead of using your time, most of it on preparing reagents, you are analyzing the results, you are also getting value out of the test that you are doing in the lab. So perhaps it's an area where we need to follow up as a region to find out if we are to move with technology, how best can we share resources, how best can we make our case for the value of whatever we want to do, so that we quickly get what is needed to inform either the patent and leave, or the public and leave, the publish and leave, other than publish and you do not publish, you perish.
Thank you. Actually, this raises something that to me has been a long-standing question that I would love to throw to the panel and perhaps the audience as well, which is sharing. Yeah. Do you have a...
I think the issue of donated equipment, the first question from our experience in my unit, we have always struggled saying whose research agenda is it? If the donor is willing to accept our research agenda and our equipment list, then we play. I think this is what happened with seeding labs. We did a brief of what research projects want to do and what equipment will make that happen. So we protect ourselves from being a dumping ground of these big, obsolete, useless equipment.
Yeah.
So that's very important. But unfortunately, sometimes when you are in the place of a beggar, you either stick to your guns and wait for a proper opportunity to come in. So we have to be very clear, whose research agenda is it? If it's mine, Then I'll tell you what I want to do and what sort of equipment will make that happen. Then you help me find the equipment. But if again I don't have a research agenda, and I'm told, oh, there's so and so with a place full of equipment, and I rush there, then you run into those problems. Then the issue of sharing, I don't know if our science community has developed to the level, like, is it Marie Curie mobility program in Europe, where then we facilitate within SADC region mobility of scientists to well-resourced labs, like what Prof was showing here, you know, so that we tend to use real state-of-the-art equipment. So a mobility program which is well-funded so that we can have access to these high-end equipment in some labs would, in my view, would be a quick solution.
Yeah, please.
Yeah, just to add on to that, I really support the idea of an established program like the ERIC program in the EU and the Marie Curie fellowships, because I think at the moment there's a lot of discussion about pooling resources and sharing equipment. And if that's not done on a very systematic and carefully thought out basis, it places a lot of pressure on the individual researcher to release equipment that they have a high demand for. There's no discussion about who pays for the reagents to run the equipment, who's going to train the students if they have to direct time from their technicians to be able to supervise the students. So I think it's a great way to pool resources and to capitalize on the equipment we already have in the South. But it's also very important that we don't just jump the gun and make this into, you know, either you share or you don't care type of situation, that we need structures in place to be able to think through it properly before we start.
So can I throw out a controversial, stupid question? So there are a number of platforms that are out there now that are essentially sort of like Uber for lab equipment, right? So individual researchers at institutions around the world can say, I have a quadrupole mass spec. If you want to come and use it, it'll cost you X dollars per hour or whatever it is. Here's my contact information. You can book the system through me. And so the people are trying to create that sharing ecosystem in the same way we've seen with Uber and Airbnb and things like that. But I guess my question is, do you think that could work in an African context? Because so far, the vast majority of labs that have joined these do not seem to be on the continent. Yeah. University administrators?
Well, I'm not sure whether I can address the question, but maybe I start by saying that you may know that the African Union has what they call the Pan-African University, which is to have, or which is supposed to have 5 different nodes, geographical nodes in Southern Africa, East, West, and Central. And the idea with that was to essentially promote and encourage higher education institutions to work together on defined continental priorities. But in addition to that, you would also find organizations, regional organizations in Southern Africa. We have SARIMA, which is supposed to promote networks and research management as well as infrastructure. The problem is, I think these organizations are not necessarily as resourced as they should be. And there is also an attitude, if I would put it that way, of universities to be hostile to each other rather than complementary. You know, the competition is good, but it must not be hostile. It should be you should be competitive in the way that you complement your counterparts. And I think this attitude is what is affecting networks and use. And of course, as I said earlier, there's also the issue of trust. How do I know really for sure that this sample that I'm sending, the results that they are going to give me are not compromised, or that the information they give me is not altered? So there's that issue of trust, and we need to face it, I think, as society. Now, the idea of Uber or equipment, would it work or not? I don't know. I think it could be tried, but we must, maybe we have to think about the context within which our society functions. What sort of values are there? Are these values the same as the ones that Uber is functioning over there? Most likely they are not. So I think it would be important to find another mechanism for use of resources. I don't know whether there is someone still here from the SADC science desk, and I think that would be interesting to hear their perspective, because part of what is being talked out there is sharing of resources and equipment, but we still have to address that a trust issue. Because again, the institutions may not have necessarily all the equipment, but the industry might have. And it's the industry that could open this up for higher education institutions. In fact, my view is that for research nowadays that is based on, or that has a commercial imperative, it is good to have the industry lead and invite the university to provide the scientific background to it. But our society is not ready for this, in my vision, at this stage.
Thank you.
So my question is around the idea of, on the basic equipment side of things, if it's at all feasible to consider 3D printing and fabrication as an approach. I mean, you can now download designs for a fully functional, accurate micropipette. You can have a fully functional microscope. And I don't know, if you could equip a resource-limited university department with a 3D printer and use that as a basis to then equip laboratories and scientists and you know, I just wondered if that is seen as a potential opportunity and solution to.
Yeah, I have thoughts about this too.
Well, actually, I mean, I'm so glad you mentioned the open hardware community. So I'm running with Eric and some other partners. We're running our first ever lab equipment hackathon in Harare in June this year, where we're encouraging students to actually build their own laboratory equipment and start thinking through using the amazing resources that you have online regarding this type of stuff. And I think 3D printing, for me, would be the logical progression towards that, well, the ultimate goal for that. I think it's a really exciting space that needs to be talked about more. And I think also, though, it'd be really interesting to start discussions about issues towards replication and validation and standard setting with regards to home-produced equipment as well.
I think that's an excellent point. There's a lab in my backyard. So it's George Whitesides, who's an eminent chemist at Harvard University. So he's got a name brand that precedes him. And his group does a lot of low-tech, low-cost, self-designed, self-generated technology. And they publish all their validation of how they've gotten and compare it to existing equipment and things like that. I think he's got a leg up because of who he is and where he is. But what I think he has sort of paved the way for is if you can demonstrate the robustness of whatever the device is you've built, that opens the door, right? I think what happens a lot of the time is using kind of hacked equipment that you don't demonstrate can actually generate robust results, and that's always the challenge, is being able to do that.
I think that's exciting, but looking forward, I think, well, taking my own background, I'm wondering, do we have a formal degree program in any of the universities in Africa which has to do with design of instrumentation? I think that's key. Do we have any measurement specialists, any university generating those? I suppose these are the people to whom all we are discussing about relates to. Yeah. You see, so a formal program which is going to train measurement scientists, be it for biomedical instrumentation, optoelectronic instrumentation, that to me would be a solution. which will also spur forward an instrumentation industry for Africa. Because apparently any measurement device we are importing.
Yeah.
That's a problem. That's a problem. Yet if you look at the bits and pieces to put together some of these things, they are off the shelf. Resistors, capacitors, thermistors, and all these things. So I think SANBio should think in terms of a program to release graduates in measurement science, practitioners for instrumentation.
I think there are a few around that I know of, but they do focus, I think, a little bit more on the repair side and not necessarily on the design side. Yeah. Yes, sir.
Thank you very much, Tanik. Mine is directed to you, Martin Gebakile from Botswana. You see, for a very long time, my country has been considered to be doing very well economically, to the extent that we were excluded from a lot of assistance. My question to you is, this donation scheme, is Botswana eligible for it?
Seating lamps.
Are there any exclusions and things like that?
Sure. I do want to emphasize, actually, that instrumental access is not a donation scheme. It's a reduced cost scheme. So, right, so we're using this leveraging system to be able to dramatically reduce the cost of equipment to you. So it costs us somewhere on the order of $60,000 US to provide about $400,000 or $500,000 worth of lab equipment. So it's a pretty good ROI, and it's been going down year upon year. We fundraise for most of that cost and then ask participants to also have a program fee kind of contribution to that. So it's not 100% free. There are very few restrictions on local geography. There are some countries that we legally cannot ship things to. North Korea is a good example. But beyond that, we're very, very broad. And I think you can find the list at our website. Yes, sir. And then I think we probably have to wrap up.
Yes, thank you. Vincent from Namibia. I think only now we are starting to hit the nail on the head when we start speaking about manufacturing, laboratory, and medical equipment in Africa for Africa. Because many times what we are experiencing is that we can acquire state-of-the-art equipment, have them shipped here from wherever in the world, whether it be China or the Netherlands, and we don't have the technical capacity to support the running, maintenance, calibration of that equipment. And this we experience a lot in Namibia. Sometimes you have to go through South Africa to get to Netherlands, and that would take a long time. It could take forever until you give up. So I think we should think of designing training programs for instrument manufacturing, repair, maintenance, and running strategically as Africa, so we can produce locally what we need instead of always depending on donations and the other. Thanks.
Thank you. Yeah. Tommy.
So I think this idea of manufacturing is a little too far ahead of our time. When it comes to manufacturing state-of-the-art instrumentation or scientific instrumentation, leave it to the Japanese and the Germans. Because they have a culture, and they are brought up with a culture of accuracy, precision, and it's a different mindset. There's no shortcuts in producing these equipment. There's no point in producing equipment for which we are then going to create inferior results. Before we go to producing equipment, what I have found in this country is that people don't know how to even use the equipment. So first learn to use the equipment, decide then that you want a modification to the equipment, and then if you have the culture of doing things right in the first place, then only think about manufacturing such equipment. Because scientific data is not for the purpose of publication. Scientific data is supposed to change lives. If we have errors in scientific data, we do not change lives. We only glorify our own mediocrity.
That's a heavy statement to end on, I think. Yes, sir.
I don't want to dialogue, but
Pick us back up, please.
I do agree that we probably cannot manufacture BMWs and Toyota Fortuners, which would come from Japan. But at least we could produce the Tatas country as Africa. Centrifuges we import in bulk. Water baths we import in bulk. I'm sure we can use water baths. I'm sure by now we know how a heating block works. That at least we should be able to manufacture locally in Africa for Africa and leave out the state of the art. That's what I'm proposing.
So in South Africa, we do have those people who produce, in South Africa, we have the people down in, I think in Cape Town, who produce the basic stuff like autoclaves. They produce hot plate stirrers, they produce ovens. I support them, I buy from them. Centrifuges, no, because centrifuges are, as we know, if something is spinning at 20,000 RPM and it's not balanced by 1 gram, you're going to have some really big issues. So therein comes the problem, because apart from just breaking the machine, you would kill the students, because at that speed. But lots of equipment are starting to be produced, even in South Africa. And to talk about the other thing about the mobility grants, South Africa, NRF and DST, they launch every 3 months an application for mobility grants. So we do have that system in South Africa already set up, and it already runs. And I receive maybe 3 or 4 grants at each time in order to send my students to use other laboratory equipment. And then with regards to the equipment as an Uber, South Africa already has that system where we have the National Equipment Database where everybody can access it. They can search for what equipment they are looking for. Then they search for the principal investigator who's in charge of it, and then they contact them. I, myself personally, have helped maybe 4 research groups per year from across the country where I do not charge for consumables or do not charge for running their samples, and I do it out of a donation. But they always access me through the equipment database. So this also exists.
Okay. I think we're getting the eye to wrap up, but can we have 1 or 2 last comments about the, I think the manufacturing issue has touched a nerve, it sounds like.
I think just a brief one. I'd like to start by saying that Germany, Japan, and the US are thriving because of diversity. It is because of the diversity, really, and which Africa has. And I really think that we must not undermine or self-doubt ourselves. What we've got to do, we know the endowments that Africa has in terms of the minerals and the skills. We have a lot of people who are very well-trained, who may even be manning stations in Germany, in Japan, in the US, who we need to bring back here. What we need to agree on is really maybe 1 or 2 institutions on the continent to focus on this issue and train our own people who can do it. Whether it takes 10 years or 30 years, let's do it. We need to start somewhere.
Thank you. Okay. Well, on that note, I hope this has generated some controversy that can continue through the tea break, because I think that only by having us all together in the room and our collective brain power do we generate some new ideas for ways to move forward together. So thank you all. Thank you to the panel so much for all of your contributions. This was really my dream conversation this afternoon. So thank you all very much, and thank you for coming.